In last lecture, we learn about path structure of assembler. In that we learn that two path translation model and a single path translation model. Now today we learn about advanced assembler directive. In the start of this program, we learn that two assembler directives are there, start and stop, and we also know the use of that. If we are using a start assembler directive like this, start and the address is specified there. At that time the address given here is stored in the location counter. Means location counter is initialized by the address given here. Means after that each instruction is given the address by incrementing according to the length specified in the mnemonic table. Means in this way we learn about start assembler directive. Now we learn about origin. Now why origin is used, or what is the job of this origin? Now origin assembler directive instruct the assembler to store the address specified in address specification in the location counter. Means if we have to change the address in the location counter during the execution of program, then we are using the advanced assembler directive origin. And what is the syntax of that origin? Like this, origin and then specify the address specification. Here the address specification becomes your operand specification or constant. Means you can specify here address using the some operand specification, like some giving us some symbol, otherwise a constant. Now the facility to provide the address specification using some operand specification, we say that we can change the address in a relative manner rather than absolute manner. Okay, means in this way the origin assembler directive is used. Like origin and then address specification, you can specify the address as a operand specification or by using a constant, means by giving a symbolic name or by giving a constant. Now consider this is one demo program, it is a sample program. Now here we use this origin directive. Now see here, origin, here also origin is used. Now what is the job of origin? Origin assembler directive gives the address given in here in the location counter. It store the address given here in the location counter. Means it initialize the location counter by using this address. Now here origin and loop plus 2. When this statement is executed, then what happen here? See. Now first start from the beginning. Now here start 200, means your location counter is initialized by the address 200. So the first instruction is associated with the address 200. Then in this way next instruction to the next. In this way each instruction is associated some address. Now here when this origin assembler directive occur, like origin and loop plus 2. Now loop means what? It's a symbolic name. Loop means what? It's a symbolic name. Now here we are changing the address of location counter by using a relative way, not by using a absolute way, because depending on the symbolic address of this loop, we change the address in the location counter. Means origin loop plus 2. Now here loop contains which address? Means loop symbolic name is associated for which address? 202. So here the location counter is associated for the address 202 plus 2, means 204, means the location counter is initialized by the address 204. Means when the next instruction is executed, the address 204 is given to that instruction. Means in this way the origin statement change the address in a location counter. Again see here, origin last plus 1. Now here origin last plus 1. Last is what? It's a symbolic name which is associated for the address 216. Now here 216 plus 1 means 2117, 217. Then here the 217 is taken as an address for the next statement, which is for A DS1, means 217 is associated for the statement A DS1 and then later 218, means in this way origin assembler directive is used to change the address in the location counter, and the syntax is origin and then you can specify the address, means here you can specify origin loop plus 2, otherwise you can specify directly origin 204. Then here we are using 204 as a constant, means the origin 204 means 204 is address is stored into a location counter, means in this way we change the address in a location counter in a relative way or in a absolute way. Then second assembler directive becomes EQU, means equal. Now here the syntax of using this equal becomes, first is symbol, then EQU and then specify the address specification, means symbol EQU and then address specification, means it simply gives the symbolic name to the address specified here, means by using a EQU assembler directive you can simply give a symbolic name to the address given in address specification. And how you can specify the address here? You can specify the address by using some constant, otherwise you can use a symbolic name with plus or minus displacement, means like here consider this example, back EQU loop, means simply what done here, loop contains address what? Loop statement contains address 202. So for the address 202 a symbolic name back is only created as a alias, means back equal to 202, means simply back is a symbolic name which is also refer for the memory address 202, means in this way we can specify here symbolic name. Constant, you can simply give back EQU 202, means constant. Otherwise if we have to suppose we have to give back as a address 204, then what we can give, simply loop plus 2, means plus or minus displacement, symbolic name as loop, and if we are giving plus 2 means it's a plus 2 means what your displacement, means after 202 204, so 204 is considered as an address for back, means in this way alias is created for the address specified in address specification, means in this way EQU assembler directive work. And next third assembler directive becomes your L2RG, means origin to literal, origin to literal. Now what is the use of this L2RG? L2RG means what? Origin to literal. Now when the literal used in your program, then how that literal is handled by the language translator is this we learn in a last lecture. Like suppose move arg comma equal to 5. Now here equal to 5 is what? It's a literal. Then how it handle? So internally the translator translate this statement as move arg @5 and @5 dc5, means in this way it create a declarative statement for the literal, means in this way the literal is handled internally by the language processor. Now here when the literal come in your program, at that time some specific address is given to store that literal, that is known as a literal pool, means in that literal pool all the literal entries are done. Like when symbol is used in a program, then symbol entry is done in a symbol table. Same here, if literal is in your program, then literal entry is performed in your literal pool. Now here by using this L2RG statement, we can specify in program that from where to store that literal, means a programmer can specify where to store the literal. Like here L2RG, which literals comes up to now 5 and 1. So here equal to 5 equal to 1 means these two literals are stored in a literal pool using this address. Means when the literal is used in your program and if the programmer want to store that literal according to its choice, according to its address, then we can use this statement, we can use the assembler directive as L2RG means origin to literal. Means in this way the literal entry is performed in the literal pool. Means here we learn about three advanced assembler directive statement. The first one becomes a origin statement. Why we are using the origin statement? If we have to change the address in the location counter, then we are using the origin assembler directive. Second one becomes a EQU statement, EQU assembler directive. Now EQU assembler directive is simply used to create the alias for the address specified in address specification. And third one becomes L2RG means origin to literal. If we have to specify where to store the literal in our program, then we are using the L2RG assembler directive.